This is part 2 of a video about this vacuum engine, and in it we're going to do a teardown, and I'll also tell you why I would not buy this again. But first let's go around and I'll tell you what the good aspects of it are. So first of all, you can see it's very nicely made. I mean, all of the work in here is very nice. You can see it's stylish. They used very good materials, so for most of it, there's a piece of steel right here, but most of it is stainless, and the flywheel is heavy-duty aluminum. It's very robust. This is also aluminum, but most of it is, again, stainless. The burner is aluminum, the burner holder, stainless. The cylinder head is cast iron, I believe. And yeah, screws are all stainless. Let's flip it up here this way. You can see that the crankshaft here, that is brass. So again, very nice material. The cylinder here is steel, and as evidenced by the magnet. Let's flip it around on this side so we can get a little better look at that side. But again, very, very nice. I mean, heavy duty all the way around, and stainless steel. So that is a lot of positives to it. If you have seen my first video, you're probably getting suspicious about why I wouldn't buy it. But let me run a section of the video I have of the thing actually moving, and that's another hint as to why I wouldn't buy it. Let's disassemble this part up in here and see if we can find out any other stuff that's going on. There's no point in disassembling the crankshaft. That's not really interesting. But let's take apart the working end of the engine. Look for evidence of why there might be any problems. Let me flip it around here so I can work on it with my favored hand, and then we'll zoom in on this section right here. Let's get the burner out of the way, and I'll show you something that I didn't like about it. The burner is not secured, I mean the two halves, and it will leak if you fill it too full and just like tip it. It'll leak around the sides, and at one point I set my hand on fire, which is, yeah, that's a bad thing. Okay, get this out of the way. and bring our engine back in here. I think what I'm going to do is try to remove these 4 screws that hold the front of the engine on here, the cylinder and what have you, and that should allow us to slide the valve off the end of that pin right there. So I've got my trusty screwdriver here, and we'll just have at that. Okay, not too bad. Keep my fingers out of the way so you can see what's going on. That's coming loose. This thing is coming loose. Okay, 2 more on this side. Yeah, even the screws are stainless, which is very nice. They put a lot of money into this. Okay, get those out of the way and get this back around for a better view. Let's see. Yeah, that comes off of there. Make sure we don't damage the piston. Got a good vacuum on it. There's the cylinder. It seems to be a metal, just some kind of a metal. So nothing special about that. It's highly cupped. It's got a Hemi piston. So there's that. And then we have our cylinder head. So this is a view of the cylinder head with the valve, like that. And I can't really see real well inside there, but it's just, it is a cylinder head. You can see there's some grooves in it. There's 2 sets of grooves. Not sure why. Actually, there's 2 rings. 2 sets of grooves. You can see the first one right there at the end of my finger. Okay, so let's even get tighter on this thing, and then we'll take it apart and see how it was constructed. At first I thought this was cast, but the magnet test tells me otherwise. This is stainless. This bracket right here, that's stainless. And this, I at first thought it was cast, but these striations on the side tell me it's probably stamped, and they don't usually stamp cast. So, and the valve, I don't know if you can see that, the valve is magnetic, which is kind of interesting. So, okay, let's remove the valve and start unscrewing stuff. When I got this originally, I checked the tightness, and this one screw down here was loose, which is not a good sign, because it means that usually when you tighten a cylinder head, you cross tighten things, and it means somebody wasn't cross tightening it. So yeah, that screw was not tight either. Okay, and these are all stainless, so construction is really, the materials are really just first rate. But I think we're already seeing the problem as to why it doesn't want to keep running. So I'll let you put your comments down there as to why you think so. There are videos on the internet already of how to fix the problem with this. So this is the valve retainer right here, and nicely polished. This is the cylinder head. Whoops, cylinder head, gotta keep that. And it sits on top of the cylinder like this. Okay, ensure we're in focus. And this is just a shim, if you will, to set the height of the retainer and so on. So there's the shim. And you can feel this, it's very smooth. So there's not like a vacuum leak around the valve right here. Notice they also split all these holes. That's because it's expected obviously to get very hot. Okay, and then there's the back side of the cylinder head. And you notice there's no gaskets or anything, there's no head gasket on here. And then here's the cylinder, and then there's the bracket. Bracket's not really anything special, just a piece of folded stainless. And then here's the cylinder, and yeah, now you can see better. There's two grooves around the inside. Not exactly sure why, but okay. Have you made your guesses as to why it doesn't keep running? Well, here it is. This is a piece of steel, and the flame comes in here. The plasma comes in here. It gets, I mean, this plasma is as hot as it gets. It's like a welding plasma or anything else. And yeah, I mean, can you imagine using an arc welder on the surface of this for any length of time? I mean, this thing's going to start turning red hot. And that's what's happening. It's turning hot. And because the engine works by taking a hot gas and cooling it off back here and causing it to shrink, well, as this heats up, the gas stops shrinking, and therefore the engine slows down and then it quits. Here are the instructions. Let's see if we can find any evidence that supports my thinking that the engine may have an overheating problem. First of all, let's scan down here and take a look at number 3 right here. Too high temperature in the air cylinder because of the continuous heating for a period of time will affect the performance of the product. Yeah, stopping is definitely a performance issue. And then up here, a little, not a strong evidence, but a little something. It says avoid other liquid substances come in contact with the cylinders in case of cylinder rustiness. In other words, don't let it rust. Extinguish alcohol lamp after finishing the demonstration. So they clearly see this as a demonstrator and not as an engine that will run continuously. Okay, so this is our teardown of it. There are several videos, I think I mentioned before, on the internet about how to fix this. One guy put a water jacket on here, and I was shocked how quickly the water began to boil. Yeah, and when this thing's run even for a few seconds, if you are foolish enough to reach down here and touch this, yeah, you blister your finger. So yeah, at least I've heard that. Yeah, so I don't know, maybe I will try to do something. I don't have a machine shop, which would be ideal, but try to figure out some kind of a water jacket. At the speed at which the water boils in this thing, my worry is that if I wrap copper tubing around here, the water in their side there would flash boil and come shooting out into somebody's face or whatever. But yeah, this is the number one reason it doesn't work. There are other products on the internet that have huge heat sinks, like down in here. And yeah, if I had a machine shop and whatever, I would machine something like this, much thinner steel, press into a block of aluminum, maybe with water cooling or just a lot of air fins on it. Okay, so that's it for this flame liquor engine, and why I wouldn't buy it again. I hope you found that useful and interesting in your home hobby experimentations.